Hi everybody. This video is going to go over how to balance a redox reaction in a basic solution. If you haven't yet watched my video on how to balance a redox reaction in acidic solution, I suggest you do that first because our steps are going to be essentially all of those steps first and then a couple additional steps. So the example that I'm going to do today, and there are lots to choose from, but the example I'm going to do today is the reaction of the permanganate ion, MnO4 negative, reacting with the nitrite ion, NO2 negative. And the products of this thing are going to be manganese dioxide, which is neutral, and the nitrate ion, NO3, with a negative charge. All right, so just like in terms of the acidic solution, what we first need to do is look at our elements here to find out what's been oxidized and what's been reduced. So just like we did before, we'll say use oxygen from the periodic table as our reference point. 4 oxygens at a -2 charge each gives me a -8. I know my total here has to be a -1 for the ion, so my manganese had to have been +7. All right. And the other side, 2 oxygens will give me a -4, and so my manganese here must have been +4. That oxidation state is going down, so this is going to be my reduction half reaction. And while we're at it, I'm just going to go ahead and separate that out down here. Because just like in the case of the acidic solution, we're going to separate these out into half reactions. And just for fun, I'm going to put a little R here to remind us that that's our reduction half reaction. We'll do the same thing with the nitrogen in the nitrate and nitrite ions, although if you really understood your polyatomic ions, you'd know that nitrite is more reduced than nitrate, so this is an oxidation. But the math for that would say I've got something -4 to give me a -1, and so that must have been a +3 nitrogen here. Over here, I have something -6 to give me a -1, and so that must have been a +5. So nitrogen is being oxidized. So that's going to be my oxidation half reaction down below. NO2 negative, this is my oxidation, is going to give me NO3 negative. All right. Now, for any redox reaction, including in basic solution, our first step is going to be to balance, or once we've separated the half reactions, is to balance our non-oxygen, non-hydrogen atoms. So balance the manganese on the top reaction. That's already done, 1 on each side. The bottom reaction, I'll balance the nitrogens. Well, that's already done too. So we can kind of skip that step. Just like before, we'll be adding in oxygen next in terms of water molecules. So I'll look at the reactions and see where I need some extra oxygens. That top reaction, I have 4 oxygens on the reactant side and only 2 on the product side. And so I'm going to be adding in 2 water molecules here to get me those 2 extra oxygen atoms. The bottom reaction, I've got 2 oxygens on the left and 3 on the right. And so I'll have to add a hydrogen to O here, getting my extra oxygen. Okay. Treating these reactions separately, I could go through and do one half reaction to its conclusion and then come back and do the other one, but I like to do them together. All right, so we've got this step. Next, just like when I did it for the acidic case, I'm going to now balance out the hydrogens that are present by adding H pluses. And now you might say for a second here, wait a second, Stamper, this is in basic solution and H plus doesn't exist for any practical purposes in basic solution. I know, we're going to get to that later. For right now, we're going to be balancing out this hydrogen content by adding H plus ions. So in the top reaction, I have 4 hydrogens on the right, and so I'm going to add 4 hydrogens on the left, again in the form of H plus ions. And in the bottom reaction, I only have 2 hydrogens on the left, so I will add 2 hydrogens on the right. Okay. Now, this is where it changes a little for basic solution. And so this now we're going to add in a step, and we're going to address your earlier concern that H plus doesn't really exist here. And that's true. Fine. You got me. What we're going to do to take care of that is to add in hydroxide ions. Remember that the solution here, the solvent for these reactions in general chemistry, is water. And so although we've written down that we have the permanganate and the nitrite ions that are being added to this test tube, we also have loads and loads of water. And where there's water, we can envision there being H plus and OH minus ions. If we were in acidic solution, we'd have tons of H plus around in relative sense, so we would have left those there. In basic solution, we don't. So we're going to convert these essentially by adding the OHs that we know are actually there. Okay, I'm going to do this in orange. We're essentially going to offset both of those, all of the hydrogens we just put in by adding in OHs. But here's the key. You're going to add it to both sides of your reaction. Okay? Why? Well, because I want it to stay balanced, right? I'm adding in extra stuff. I'm not just balancing things like I was before. I'm actually adding in brand new things. And so I'm going to add it to both sides. I'm going to do the same thing on the bottom reaction. I put in 2 hydrogen ions, and so since we're in basic solution, I've got to add 2 hydroxides to both sides. Okay? And now the key thing to kind of recognize here, I'm going to go to some other zany color, we'll go with purple, is that if I have 4 OHs and 4 Hs, or down here, 2 Hs and 2 OHs, if I have those pairs, that's really representing a number of water molecules. And so I'm going to substitute here. I'm going to rewrite it with water taking up those spaces. All right? So I'm going to rewrite this. My top reaction now will have 4 water molecules. That's the result of combining my 4 H's and 4 OH's together. And I still have my permanganate ion, giving me my manganese dioxide and the 2 waters that were there from before, and those 4 OH's that I added in. Right now there's no trace of H plus anymore, which gets us into that basic solution kind of mindset. I'm going to do the same thing at the bottom. 2 OH's and a water and a nitrite ion, giving me a nitrate ion and now 2 water molecules. Okay, I've combined the 2 H's and 2 OH's to give me 2 waters. That's basically the only change for the basic solution, just those 2 little steps. Now we're back on the kind of main point of all of this where we're going to balance our charges. So when I look at the top half reaction, I see the only charged species on the reactant side is a permanganate, total charge of -1. On the right side, I've got those 4 OHs that I put in there, so a total of -4. And so I need to add electrons to make those charges balance. Essentially, I'm going to add 3 electrons to the left side to bring its charge down to -4 to make it match. Now, in the bottom reaction, I'll do the same thing. I've got 2 hydroxides and a nitrite, so a total charge of -3 on the left. On the right, I only have a charge of -1 with a nitrate ion, and so I need to add a couple more negative charges here to make them balance. Right, I'm adding electrons so I can only bring the more positive charge down to match the more negative charge. Again, like I said before in the other video, at this point you should have electrons going into one reaction and coming out of the other. And if you don't, you've done something wrong. One of them has to be reduction, one of them has to be oxidation. All right. Now, again, just like we said in the previous video, if we're considering these 2 half reactions together, as we are in this problem, we need those numbers of electrons to match each other. And so we're going to multiply to get essentially the least common multiple of those electron numbers. I've got a 3 electron and a 2 electron. The least common multiple here is going to be 6. So I'm going to multiply my entire top reaction by 2. So 2 times 3 electrons will give me 6 electrons. And I'm going to multiply my entire bottom reaction times 3 again so that the electron count is going to get up to 6. All right, so I'm going to rewrite it, doing that multiplication as I go. So the top reaction, 6 electrons plus 2 times 4 is 8 waters plus 2 permanganate ions, giving me 2 manganese dioxides. 2 times 2 is 4 waters, and 4 times 2 is 8 hydroxides. Right? Now, if I did that right, we'll be all set. Multiply the bottom reaction. 2 hydroxides times 3 is going to give me 6 hydroxides plus 3 waters plus 3 nitrites, giving me 3 nitrates, 6 waters, and 6 electrons. All right, now I'm going to combine these reactions together and simplify where I can. Okay, so bear with me here. I like to do this all in one step, but I'm going to make sure I'm not oversimplifying, okay? First, my electrons are going to cancel. That has to happen. If my electrons don't cancel, then I did something wrong. So get a new sheet of paper and start over. And then it's up to you how you want to handle this thing. I don't trust myself sometimes to, not screw something up. So I'm going to write this out one more time without the electrons. And I'm going to combine together, as I'm combining the top and the bottom half reaction, I'm going to combine together like terms. So, in chemistry, it doesn't matter what order you write these things in, but I've got 6 OHs. And now I've got 8 waters in the top reaction and 3 more waters in the bottom reaction, so I've got 11 total. And then I've got, let's see, so I took care of the OH, I took care of the waters, I've got my couple of permanganates and my nitrites, okay? And then the other side, I've got my 2 manganese dioxides. I've got my 3 nitrates. I've got 4 waters on the top and 6 waters on the bottom, so that's 10 waters. And my 8 OH ions. Okay? If you're smarter than I am, you can just skip this step. But I like to write it out so that if I did mess it up, if I check my answer at the end and it's not right, I can go back through my work and see where I messed up. So by doing this now, I see I do have some common things on the starting and the ending part of this reaction. I can cancel those out. So here's 6 hydroxides on the left. I can take away 6 hydroxides on the right. That'll bring me down to 2. Likewise, I've got 10 waters on the right. So I can take away 10 waters on the left, which I'm going to write a 1 here. Of course, you don't need to write a 1, but just to show that there is still 1 there. And I don't see anything else. I've got my permanganate, I've got my manganese dioxide, I've got, the nitrogen species, and that's it. So now, finally, drum roll, we can write out my final ending overall reaction. I've got a water molecule still over here on the left, 2 permanganate ions, 3 nitrite ions, giving me 2 manganese dioxide species, 3 nitrates, and I still have 2 OHs hanging out over here. Okay, and that's it. That's the final step. Nothing else I can do with it. If you were to go back and check this reaction, you'd see that all of the hydrogens and oxygens and manganese and nitrogens still balance. All of the charges still balance. And if I were using this for electrochemistry, if you were in that chapter and you were dealing with this in electrochemistry, I know from earlier work that this was a 6 electron transfer. I'm just not showing the electrons here in the final result. So that's it for now. Check the description of the video for a link to the rules that I just went through in kind of an outline format. And good luck with your problems.